As I approach the last example for our algebraic situation today, we have one more example under elimination, but this is the most unique of the four. So as we go through it, if you feel that you have any questions, again, please remember that you can always send a remind message or set up a meet if need be. So one of the things I noticed immediately is that they're not even in order. The x squareds aren't before the y squareds. If that bothers you, you are welcome to fix that and reorganize it. Certainly I think it's never a bad idea to do. It also might make you pause for a second to think about what kind of shape both of these equations represent, because that might inform you as to how many points of intersection are possible. So I notice that I have a positive and a negative on my coefficients. That makes this first one a hyperbola. I notice I have a positive and a positive, which makes my situation an ellipse. Now these are not in standard form by any means, but I certainly can make that connection as to what the graph is. Now if I'm looking for an elimination, I have to decide whether or not I'd like to eliminate the x's or the y's, and to be honest, it's completely up to you. I might make the choice to eliminate the y's merely because I already have a negative in the problem. So if I were to take this equation and multiply the whole thing by 2, I'll do that down here below. I'm going to have a 4x squared, a 2y squared, and 108. And so that represents the second equation. I'll copy over my first equation, and then I'll, as you know, line them up vertically. Now this is a 4, just for in case that was hard to read because of the fanciness. Alright, so when I add them vertically, I'm going to get a 5x squared, and I'm going to get 125. Now as I finish simplifying that to figuring out the x value, I want to remember one more time that I'm going to get a positive and a negative once I take the square root, because there are two possible values for that. And what I want to do is take each 5 and negative 5, so one of them will be red. Okay, we'll make the positive one red, and we'll make the negative one turquoise. Okay, and we're going to substitute to figure out what each of those gives me. So when I set up my red 5, I can put it in either equation. Again, keep in mind that the x is 5, so don't accidentally put it in place of the y. So I'm going to have 5 squared minus 2y squared equals 17. Again, I chose that equation, slightly smaller values. So 25 minus 2y squared equals 17. Gives me 2y squared is negative 8, and y squared is 4. So when I do that, I get 2 y values. So this one singular red 5 gave me 2 y values. So right now I know that 5 can go with 2, and 5 can go with negative 2, because I saw that happen through my process. Now, if I were to take the negative 5 and put it into that same first equation, again I'm using the modified one where the x is first, then I'm going to see again, similar to what I saw in a previous example, that there might be a shortcut of work that I can notice. I can notice that this line and this line are already identical, and probably predict, though I'm welcome to finish, the calculations, it never hurts to make that choice, and to figure out that the negative 5 also gives you those same values. So negative 5 can be paired with positive 2, and negative 5 can be paired with negative 2. So there are actually 4 total solutions to example 4.